Hello everyone. So today I'm just gonna walk through some problems, general problems from past handouts, especially the proof writing techniques. Um, there can be some problems. I'm gonna walk through some Putnam AP more problems, some or more of the harder problems that you wanna actually think about. So they're not necessarily hard, but I think sometimes you're just missing the key intuition or continuity in this case. So what I'm gonna essentially do is I'm gonna walk through some problems and give general advices and tips on how to actually conquer these problems or like conceptualize the ideas for those problems. Now, some of the problems are really hard and some of the problems require further techniques, but probably it's gonna be much more funner. Okay. Now, okay. So wait. Okay. If you recall the fact that let's prove number 9. So the product of two integers is divisible by 4. Well, this is easily proven since we have that if let's say for positive integers a and b in the set of natural numbers, we have that the even numbers are in the form of 2a and 2b, and if you multiply that together, this gives us 4ab, which is congruent to 0 mod 4. So this is generally how I advise how to actually do the problem. I think it requires a much more number theory than it actually does. So probably I'm gonna skip that for a minute. So now let's look at this pattern problem. So if you have an arbitrary infinite sequence un that reaches to infinity, if u0 is equal to u1 or equal to u2 such that it is equal to 1, thereafter the condition that the determinant of this particular matrix un plus 1 with riches is equals to n factorial. We need to find the overall structure for un. So O of epsilon is equal to 0. So okay, just general advice. How do you even approach this problem? So I would probably say you actually need to find a structure. Guess the particular structure here. So in this particular case, we have that the determinant is equal to some diagonal matrices un times un plus 3 minus un plus 2 un plus 1. So run a few test cases and then just see the particular pattern there. You're usually going to find a particular pattern and you can actually prove this by induction. That's why it is in this handout. So let's just go over through and implement this. So okay, so let's say u0 0 is equal to u1 by definition is equal to u2 is equal to 1, and for n greater is equal to 0, we know the determinant of the matrix with entries u un plus 1 un plus 2 un plus 1 un plus 2 un plus 3 is equal to n factorial. Am I right? Okay, this is the general problem. Now, so first test case is to check for n equals 0. So we have that for n equals 0, let's just, I think we can just probably put it here. So this is the number of n, and I think what's the determinant for a n squared? So this is the number of n and then un, let's say un. So for n equals 0, our un is actually, so it's 1, 0. So the determinant is just gonna be 1. So it's just gonna be un plus 3, So 1 un plus 3. Sorry for my handwriting. I think it's 12 of noon. It's about 12 o'clock. I guess I have no life and have no fates either. So just sorry for my handwriting in general. So we have minus 1 is equal to actually n factorial. In this case, it's 1. So un plus 3 is actually equal to 2. Or un 3 is equal to 2. Now, let's say the general case for un. So for n1, 2, 3, 4, 5, 6, 7. So 1, 1, 2. So now we need to find for arbitrary, let's say for 1, we have that the diagonal matrix of this particular matrix is going to be 1, I guess 1, 2, 1, un plus 4, right? And this is just going to be 1, 2. So we have that un plus 4 is actually equal to 3. Now for n equals 5, this is also easily proven. We can find the congruent value for this. So let's just go with the implement this, right? So we have that the determinant of this matrix is going to be so the diagonal matrix of u1, so it's going to be u2, I guess. Okay, so u2 okay, sorry, u1, 1, 2, 3, un plus 3, or un5, and that's the determinant for n factorial, which is just 4. So u5 is equal to 10. So I think just running over all of the test cases, you can actually find the pattern here. So what's the pattern here is that for all un, we can actually find a sequence that is such that it's n double factorial. Such, let's say for 5, we're gonna get 5 times 3 times 1. For 4, we're gonna get 4 times 2 times 1. Let's keep a number between them. Yeah, I think that's it, and then you can just prove the general case by induction, which is left to the reader as an exercise. Now let's look at this problem from the Asian Pacific Mathematical Olympiad 2024. I guess I think this problem was necessarily, it does not require that much more knowledge about proof techniques and like a theory in general, but it requires some general advice, I think. And we need to actually prove the base case. So the base case here is that for n equals 1, we need to prove that the following holds. So if a1 is the positive sequence, we can actually prove by algebraically for the general case, and then for some k plus 1, if we actually minus both sides by k plus 1 or minus by this, it's going to be actually less than or equal to this particular function. So that's, I think, the iterative approach here. But I think, honestly, you can do by yourself. It doesn't really matter what you actually do, but it's still actually really fun to do those problems. I'll say as a whole, it's actually changed a lot. So I think, yeah, this one. So let's do the IMO P6. Don't worry, it's actually I think this is considered really hard for mathematical competitions. But generally, my general advice is probably don't focus on the really hard IMO problems. Focus on some IMO problems 1 or 4 if you're just trying to enjoy some problem solving. Since it's less likely that you're gonna encounter this competition in the future unless you're like me with no life, with no social anxiety, and trying to destroy every possible competition. But generally here, what it does is you don't necessarily need to do something that is actually done in arbitrary functions. So uh, it's great to know some techniques, but it doesn't really matter if you solve hard problems unless you enjoy to do so. Now let's just go through some problems. So let a1, a2 be distinct positive integers. Let m be a set of n minus 1 positive integer which does not contain the set of prefix sums. Grasshopper jumps along the real axis of 0s, making n jumps from right lengths in the same order. So we have a grasshopper here. And let's say our g1 in some order from 0, s minus s. That is such that we choose in the way of grasshopper lands on point m. So we can choose some point m. So okay, we can prove the general case that's for grasshopper jumping at some point ai aj. Now I think here is actually to understand the problem is the hardest thing. Then it's gonna be really easy once you simplify it. I'm gonna leave it as an exercise. Uh, so what problem should have covered first? Let's do the general cases. So the next video is gonna be about linear algebra and analysis. If you don't have knowledge in those fields, I would suggest like read some books or know the general theorem. I'm just gonna go through general theorems in linear algebra, so you don't actually not have to know it, but you need to know the basic operations of matrices, which I'm gonna cover tomorrow, in the next video. So, thanks for watching. I think this handout helps. I think in the better future, I hope I'm gonna film my videos a bit earlier, maybe. I don't really mind. Now, uh, so yeah, I think let's go. Thank you for watching the video. Bye.